All right, thank you so much for joining us today. In this video, we're going to consider case 3, and we are going to look at exponential and polynomial function together, right? So here we said anytime we have exponential and polynomial function together, we are going to consider a trial solution. So this is the first thing that we need to have it in mind. As soon as we have this and this is kind of bonus. Just multiply this one by x and then multiply by x squared and you get what is here, right? So now let's take example and look at how we can go through the process. So same process again. Here too, we are going to consider a general solution. So with the general solution, we are going to consider y is equal to the solution of the complement and then the particular solution. So we are going to start by saying that for the complementary solution, we are going to let y prime prime plus 3y prime plus 2y to be equal to 0. So this is the homogeneous aspect. So let's go through the process. Y is equal to e to the power mx, y prime is equal to m e to the power mx, and y prime prime is equal to m squared mx. So let's just do substitution. Plug this one inside this. We are going to have m squared e to the power mx plus 3 times m e to the power mx plus 2 e to the power mx is equal to 0. We are going to factor e to the power mx out. It will be left with m squared plus 3m plus 2 is equal to 0. So assume that this is never 0. Then we are going to have the polynomial function, which is the characteristics polynomial, to be this. And then for us to find the characteristics root, we need the characteristics equation, which is this is equal to 0. So as I said, we can use the quadratic or we can use factorization. So here I'm going to use factorization. This plus m plus 2m plus 2 is equal to 0. So 1 times 2 is 2, and then 1 plus 2 is 3. So this one works. So now the one with the red and then the one with the green. So the one with the red is going to give us m plus 1. The one with the green is going to give us 2 out, m plus 1 is equal to 0. So when I factor m plus 1 out, it will be left with m plus 2, which is equal to 0. So this one helps us to see that we are going to have m1 to be 1, and then m plus 2 is equal to 2, is equal to 0, and m2 is equal to minus 2. So these are distinct roots. So our complementary solution is going to give us c1 m1x plus c2 m2x. And as I said, we are going through the same process. The only thing that we are changing here is how to guess the trial solution for the particular solution. So this is going to be c1 x plus c2 e to the power minus 2x. So this is the complementary solution. So the next thing that we want to do is now we want to find the particular solution. So let me write the question here so that we can put them together. Y prime prime plus 3y prime plus 2y is equal to 6x e to the power x. Is that right? Good. And then our complementary solution is yc is equal to c1 e to the power x plus c2 e to the power minus 2x. I think that's right. Good. So now that we have the complementary solution and we know that general solution is a complementary solution in addition to the particular solution, then we need to consider the particular solution. So we know that this is a polynomial and exponential, right? Exponential function. So we are going to consider this trial solution a constant, and then we need to also consider the polynomial function, but the polynomial function here is kind of to the power 1, right? So we are going to have something like, we are going to have something like this, a polynomial function. So we are going to have this plus a1 x times the exponential function here. So we are going to have this. So this is the first trial solution because this is a polynomial function and exponential function. So we use the exponential function here, and since this one is having order 1, we need to have a linear function here multiplying this. So this is the trial solution. So let us multiply and see what we are going to get. A naught e to the power x plus a1 x e to the power x. Now we compare this to the complementary solution to find out if there is nothing the same. So we have e to the power x also here. We have a constant, we have a constant. So basically this and this, because of this and this, we need to modify our trial solution. So how can we do that? We can modify our trial solution by multiplying through by what? X. So when we multiply through by x, we are going to have, so I want to multiply this one by x. I want to multiply this one by x. So I'm going to have a naught x e to the power x plus a1 x squared e to the power x. So it means that the first trial solution, we are going to take it out because it's not going to work because we have one of them there. So this is out. Now let's consider this. Let us consider this here. Now the one with the e to the power x is just this. This one too is the e to the power x. So we are not interested in this because this is e to the power minus 2x. So now this is going with x. There is no x here. This is going to with x squared. There is no x squared here. So it means that this is what we are going to consider as our trial solution for the equation. So let's see what we are going to get from here. So this is our trial solution for the particular solution. So now what we just need to do is we just need to differentiate. So y prime of p is equal to, this is a product rule. So I maintain my a naught, then I use the product rule to differentiate this. So when I differentiate product rule, x will give me 1, e to the power x will give me e to the power x. So I'm going to have x times this and 1 times that. So I'm going to have e to the power x plus x e to the power x. So that's what I'm going to get, plus a1 out, product rule for this one too, but this one we have x squared, and we have e to the power x. So when I differentiate x squared, I'm going to have 2x. So when I finish, this times this and then this times that. So that's the product rule. So I'm going to have x squared e to the power x plus 2x e to the power x. So this will be the first derivative. Now I need to find a second derivative. So a naught, when I differentiate this, I get the same thing again, plus when I differentiate this, remember this was the same as this, and when we differentiated this, we had the whole of this. So when I differentiate this, I will have the same thing as this using the product rule. So I'm going to have ex plus xex. So maintain this and differentiate x, you get 1, plus now maintain x and differentiate this, you get the same thing as you can see from there. Then plus a1, when I differentiate this here, I'm going to have x squared e to the power x plus 2x e to the power x by the product rule. Then the last one is when I differentiate what is also there. This one we have 2 in addition. So when I maintain 2x first and I differentiate ex, I get the same thing. Plus now I differentiate 2x, I'm going to have 2 and then I maintain this. So this is going to be my function. So what I'm going to do is I'm going to plug in this, and this inside this and solve. But what I can do is I can try and simplify this before I do the plugin. So a naught e to the power x plus a naught e to the power x plus a naught x e to the power x plus a1 x squared e to the power x plus 2a1 x e to the power x plus 2. I can even add this and this so that I get 4 from there. So when I add those two terms, I'm going to have 4. So it will be 4a1 x e to the power x plus 2a e to the power x. Good. So that's what I'm going to get from there. Can I group any terms? These are all a naught. Okay, I can add this term and this term from here. This plus this will be 2. So I can even write this one as 2a naught e to the power x. So apart from that, I cannot add any term again. So that's what I'm going to get at the end of the simplification. Then I can substitute them inside this. So let me write y prime prime is equal to the whole of this. So I'm going to have 2a naught e to the power x plus a naught x e to the power x a1 x squared plus 4a1 x e to the power x plus 2a1 e to the power x, then plus 3 times y prime. So this is y prime. So I will simplify it whilst I'm writing. So I'll multiply a naught through. So I'm going to have a naught e to the power x plus a naught x e to the power x. Then plus, I will simplify this one too. So I'm going to have a1 x squared e to the power x plus 2x a1 or 2a1 x e to the power x. So this will be y prime. Then plus 2y. So y is equal to what is here. So I'll write that one, then I'm done. So let me bring it down here. So plus 2 times y. Y is a naught x e to the power x, a1 x squared e to the power x. So here you need to pay attention to the expansion too, and this one should be equal to e to the power 6x e to the power x. Yeah, so I think we have 3 examples. This is the first one, right? Yes. This is the first example. When we are done, we have 2 more, and then I'll give you trial question to try. So stay here so that you can see different form of solving this. So now we need to expand and then try to see what we can get. So I can copy this because I'll write it again and paste it here. Good. So let me copy and paste. Then so this I'm going to write it again. So I just paste it here. I'm going to multiply through by 3. So when I do that, I'm going to have plus 3a naught e to the power x plus 3a naught x e to the power x plus 3a1 x squared e to the power x plus 6a1 x e to the power x. So this is for this one. And then the last one to expand is this. So I'm going to have plus 2a naught x e to the power x plus 2a1 x squared e to the power x, which is equal to 6. So this one will be equal to 6x e to the power x. So let's try and group like them. Constant term, the terms with x, and the terms with what? X squared. So let me look for constant term. This one has no x. Let me see again. This one also has no x. This one also has no x. Okay, done. So the ones without x, we have this and this. And you see that this is a naught ex, a naught ex. So I can add it and have something like 5 a naught x. And then I'll add plus 2a1 ex. So I just added this, this, and that. They are the terms without x. Then let's add the terms with x. Terms with x is, this one is having x, this one is having x, this term is also having x, this term is having x, and this term is also having x. So let's see the one with a naught. So this one is a naught, this one too is a naught, and I think this one too is a naught. So 1 plus 3 plus 2 is going to give us 6. So we are going to have plus 6 a naught e to the power x plus, so I just pick this, so let me use something to take it out. So I added this, this, and this, so it's left with this and that, which is also going with a1, a1. So this is going to give us plus 10 a1 e to the power x all times x. So I wanted to factor the x out, that's why I didn't bring the x attached to this and that. So now that we are done with all the terms with x and without x, we move to the terms with x squared. So the one with x squared, we can see this, this, and that. And we can see that all of them are in terms of a1. So this is a1, a1, a1. So when you add them, we are going to have 6. So you're going to have plus 6 a1 x squared e to the power x, which is equal to 6x e to the power x. Good. So now let's see what we can do from here. Let's see what you can do from here. So now, since this is a polynomial function going with x and ex, what I'm going to do is I'm going to factor this es out, here, so that we can combine it to the other side. So I'm going to have 5 a naught plus 2 a1 to the power ex plus, this is 6 a naught plus 10 a1 e to the power, this one will go out, e to the power x plus 6 a1 x squared e to the power x, which is equal to 6 s e to the power x. So now we are going to compare terms. So we can see that we have x ex here and we have x ex here. So when I compare the coefficient, they should be the same. So the first one is going to give us this plus 10 a1, and this should be equal to 6. Right. Now we don't have any term on the right that has x squared e to the power x. So it means that the coefficient of x squared e to the power x will be equal to 0. So 6a1 should be giving us 0, because we don't have any term on the right that goes with x squared e to the power x. Now let's look at this one too. We don't have any term on the left that has e to the power x standing alone. So this one is going to be also 0. So you need to pay attention here so that you don't say that the coefficient of this is this, so you are going to pick this one to be the same as this. No, we can't have x in what we are getting here. So this one should be 5 a naught plus 2 a1, and this one should be equal to 0. So from here we can see that a1 is automatically 0, right? And if a1 is 0, then when I plug in a1 here, this is going to give me 6 a naught, which is equal to 6, and it implies that a naught is 1. And then since a1 is 1 is 0, then what will be a naught? So if this one is 0, it means that a naught will be 0. So it means that there is a mistake somewhere, because we cannot have a1 to be 1, and then we cannot have a naught to be 1, and then when I plug in this one here, I'm going to get a naught to be 0. So let me just go through the solution very quick and see what we had from here, starting from here. So this one, when I multiply this one, this is right. So our root is, okay, so that is the mistake that we made. So this supposed to be 0, and oh, that is a big mistake. This is supposed to be -1. So this is kind of very big mistake that we've done. So it means that the complementary solution, this is going to be minus. Good. So it means that we need to change some things. Oh, we've done cos 90 job. Okay, it's fine. So what we are going to do here is, it means that our trial solution is going to change again. So these are all not. So you see the reason why I saw this one here, it's because I'm not going to get the solution because of the mistake. So let me clean up the whole of this, and then let me call the solution again, the trial solution again. So the first trial solution that I'm going to call is the a naught plus x1 e to the power x. So it means that we are not going to have e to the power x in our complementary solution. So this will be the trial solution. So this is going to give us x naught, a naught e to the power this plus a1 x e to the power that. So this one we are not going to do any modification because we don't have any e to the power x here. So that's what we are going to get from there. So let's differentiate. Let me go through quick because this is going to give us, when I differentiate this, I'm going to have x a naught this plus, when I differentiate this, I'm going to have a1 e to the power x plus x e to the power x. So that's what I'm going to get. Prime prime, this is going to give us this plus a1. When I differentiate this, I get the same thing, plus when I differentiate this, another product rule, so I'm going to have ex plus xex. So that's what I'm going to get. Then let me just simplify them so that we can just do substitution fast. I think this one will be very fast. So when I simplify, when I add this one, I'm going to get 2. So it's going to give us 2a1 e to the power x plus a1 x e to the power x. And then when I simplify this, I'm going to have a naught plus a1 e to the power x plus a1 x e to the power x. So let us plug this, and this inside the original solution. So I'm going to have x naught or a naught x plus 2x1 e to the power x plus a1 x e to the power x plus 3 times y prime. So y prime is this. So multiply by 3 e to the power x plus a1 x e to the power this. And because we did a mistake, I just want to run through fast. And then 2 times y, right? Yeah, 2 times y. What is y? Okay. Y is a naught e to the power x plus a1 x e to the power x. Is that right? Yes, of course, that's right. And this one should be equal to 6 e to the power x. Good. Now let's do the expansion and then we take it from there. X naught a1 e to the power x plus a1 x plus 3 a naught e to the power x plus 3a1 e to the power x plus 3a1 x e to the power x plus 2a naught e to the power x plus 3a1 x e to the power x. So 6 that. Good. So I just wrote this one here again, multiply through by 3, and then multiply this one by 2, and then equal to that. So now let's group like terms again as we were doing. We group all like terms without x with x, and then we just go. So we have without x is this guy. This one too is without x. This one too without x. This one too without x, and this one too without x. But we can see that some of them is with a naught. So this is with a naught. This is also with a naught, and this is also with a naught. So we can add them So 2, 3, 1, 6. So you are going to have 6 a naught e to the power x. Now let's go with x1. This is x a1, and this is also a1. So it's going to give us plus 5a1 e to the power x. So these are the terms without x. Let's look at the terms with x. This is with x, this is also with x, and this is also with x. And they are all the same. So 2, 3, 1, even as 6. So you're going to have plus 6a1 x e to the power x. And this will be the same as 6 e to the power x. Good. So what can we see? The term here, x ex, we have x ex. The coefficient of this is x, and the coefficient of this is 6a1. So we are going to have 6a1, which is equal to 6, and then a1 was 1. Good. So you saw that the other one, the mistake that we did, a1 2 was 1, but looking for the other one too, a1 was different. So now the constant term, let me write the constant term. So the constant term, I should have factored e to the power x out. So let me do that. Factor e to the power x out, and we are going to have something like this. This is plus 5a1 times e to the power x. So we don't have any term here with e to the power x. So we assume that the coefficient is 0. So this is going to give us 6a naught plus 5a1, which is equal to 0. a1 is 1. So 6a naught plus 5 times 1 is equal to 0. 6a naught is equal to minus 5. And then a naught is going to give us minus 5 over 6. Good. So this is now right. So now our solution, our particular solution, which is from here, now we can write it as yp, which is equal to a naught is minus 5 on 6 e to the power x, and then a1 is 1. So we are going to have plus x e to the power x. Now we add these two together and we get the general solution. So our general solution is going to be, let me see, y, which is equal to c1 e to the power minus x plus c2 e to the power minus 2x minus 5 on 6 e to the power x, and then plus x e to the power x plus x e to the power x. So this is the general solution that we are going to have. Good. This is the general solution that we are going to have. So you see the way I made just a mistake with the root and it was just running through. So that's the reason why whenever you are doing it, you need to pay attention to that, because one mistake is going to make everything wrong. So because of this one, I made it positive. It was making everything wrong. Good. So pay attention to that. Let's take another question, different form. Another question, different form, and let's go through. So for general solution, we are going to have y to be equal to yc plus yp. Then for the yc, what is the complementary solution? Y prime prime minus y prime minus 6y should be equal to 0. So what are we going to get from here? We are going to assume that y is equal to e to the power this, y prime is equal to m e to the power mx, and then y prime prime is equal to m squared mx. So guess what is going to happen here? We do substitution, we get this minus m e to the power mx minus 6 e to the power mx is equal to 0. Factor e to the power mx out, m squared minus m minus 6, and this is going to be 0. And set this one not equal to 0. then the characteristics polynomial is equal to m squared minus m minus 6, and we are going to set this one to 0 so that we can find the root. So I can see that this is not going to give us complex, so I can do the factorization. So this is going to be something like this. Yes, so I can do factorization from this. So this is m squared minus 3m plus 2m minus 6 is equal to 0. So 3 times 2 is minus 6. I said 3 times. Minus 3 times 2 is minus 6. And then minus 3 plus 2 is minus 1. So now I go with the blue, then I go with the green. So with the blue, when I factor m out, it will be left with m minus 3. And with the red, when I factor 2 out, it will be left with m minus 3. Now factor m minus 3 out, and it will be left with m plus 2 is equal to 0. Here, let's pay attention here so that we don't make mistake here. So here, m1 will be 3, which is right. And then m plus 2 is equal to 0. And m2 is going to be minus 2, which is also right. So no mistake here. So our complementary solution will be C1 m1x, C2 m2x. So yc is equal to C1 e to the power 3x plus C2 e to the power minus 2x. So no mistake here, which is good. So now that we've gotten the complementary solution, let's try and write out the particular solution. Y prime prime minus y prime plus 6y minus 6y is equal to x squared e to the power minus 2x. Good. We had the complementary solution to be c1 e to the power 3x plus c2 e to the power minus 2x. Is that right? Yes. So now let's try and find the particular solution. Let's try and find the particular solution. So for yp, which is the particular solution, since this is involved with polynomial function and exponential function, we are going to have yp to be equal to, so remember this is squared, so we need to write it as a quadratic function. So a plus a naught plus a1 x plus a2 x naught times exponential function, which is here, so e to the power minus 2x. Let's try and expand and see if we don't have problem with that. So a naught e to the power minus 2x, then plus a1 x e to the power minus 2x plus a2 x squared e to the power minus 2x. So let's check if we have e to the power minus 2x inside our complementary solution, which is yes, we have one of them in. So it means that we need to check. So we can see that the one with e to the power x, this is almost the same thing here. So because we have a constant and then e to the power minus 2x, e to the power minus 2x. So we need to modify this by multiplying through by what? X. So this is going to be yp, which is equal to, so multiply through by x so that we modify it. So x naught x e to the power minus 2x plus a1 x squared e to the power minus 2x plus a2 x to the power 3 e to the power minus 2x. Good. So this is what we are going to get from the yp. Now when you compare, the term here starts with x and this one has no x, so it means that now this is the right choice for our trial solution. So you see the way I need to start with the first one, and then when I'm done, that is when now I need to think about checking with the complementary solution to see if there is no term which is the same as in the particular solution. Then now I take it from there. If there is a term which is the same thing in the complementary solution, then I modify it by multiplying through by what? X. So now let's see what we are going to do here. We are just going to take the derivative. This is going to be very long with the derivative. So y prime, this is a product rule. Okay, so I'll make the derivative very short. Because of that, I'll write this one as, I'll factor e to the power minus 2x out. I want to make it short because if not, it will be plenty here. A1 x squared plus A2 that. So I'm just using this strategy so that the derivative will not going to be long. So y prime is going to be, so I'll just use product rule for these two functions. So I maintain this, then I differentiate this. So maintain e to the power minus 2x and differentiate what is inside the bracket here. So when I differentiate this, I'm going to have a naught plus, when I differentiate this, I'm going to have 2a1x plus, when I differentiate this, I'm going to have 3a2x squared. Then plus, let me shift this one here, plus, now I'll maintain a naught x plus a1 x squared plus a2 x to the power 3. I maintain this and differentiate this. And when I differentiate e to the power minus 2x, this is going to give us minus 2 e to the power minus 2x, right? So it means that I can modify this equation here and write it as, I want to bring the minus 2 first, so minus 2 in front, then I have e to the power minus 2x here. So this will be the first derivative. Now let's take the second derivative. Now the second derivative is going to give us something like this. So we need to apply the product rule here. So I first maintain this and differentiate what is inside the parentheses. This one will be 0. So I get 0 plus this one is going to give us 2a1 and this one is going to give us plus 6a2x, right? Then plus, now I need to maintain this and differentiate the whole of this. So when I maintain this, we know that when I differentiate this, I get minus 2 times this. So I'm going to have minus 2 a naught plus 2a1x plus 3a2x squared e to the power minus 2x. So I'm doing product rule. I maintain this, I differentiate what is here, then I maintain this, which is here, and then I differentiate this. But this is going to give us minus 2 this. So that's what we are going to get from there. Then I'll move by the last one here. I need to differentiate this one again. So I'm going to maintain this and then differentiate this. So I'm going to have minus 2. Then when I differentiate what is here, I'm going to have a naught plus 2a1x plus 3a2x to the power 2 e to the power minus 2x, right? So I just maintained this and the minus 2 and differentiated what is inside the parentheses. Now I'm going to maintain minus 2 and this and differentiate this. When I differentiate this, I get minus 2 this. So this is going to give us plus 4 a naught x plus a1 x squared plus a2x to the power 3 e to the power minus 2x. Good. So this will be the second derivative. So it means that we are going to do a lot of expansion here. Now let's go and plug them in. So we have y prime. So I'll write the y prime again. So whilst I'm writing the y prime prime, I will simplify it. So I'm going to have, I'll multiply this one through, right? So this one will get to 0. So I'm going to have 2a1 e to the power minus 2x plus 6a2x e to the power minus 2x. So please follow with me and multiply this by this and that, which is here. Then I'm going to multiply the minus 2 through this with addition to this. So I'm going to have minus 2a naught e to the power minus this. So multiply this one by this and this. Then the next one will be minus 4a1 x e to the power minus 2x. Then minus 6a2 x squared e to the power minus 2x. Then multiply through by minus 2 through again here. So I'm going to have minus 2 a naught e to the power minus 2 this minus 4 a1 x e to the power minus 2x minus 6 a2 x squared e to the power minus 2x. Good, good. So this is what I'm going to get. Then the last one I multiply through by 4. I'm going to have plus 4 a naught x plus, is this supposed to be x? Yes, it's x plus 4 a1 x squared. This is x. I just confused my own self. And then this one is going to be 4 a2 x to the power 3 e to the power minus 2x. Okay, let me add e to the power minus 2x to this, and then also add e to the power minus 2x to this. So you see, the expansion is so crazy. So when you are doing it, you need to take time. Then minus y prime. So what is y prime? This is y prime, right? So minus of this. So I'll do the expansion whilst I'm writing. I will use red for that. So I just want to do expansion for this, but remember it is minus what? Y prime. So we are going to have, when I multiply this through, I'm going to have minus a naught e to the power minus 2x minus 2 a1 x e to the power minus 2x minus 3 a2 x squared e to the power minus 2x. Remember, I'm multiplying through by minus, so this one becomes positive. So I'm just going to multiply positive throughout. So I'm going to have plus 2 a naught x e to the power minus 2, then plus 2a1 x squared e to the power minus 2x plus 2 a2 x to the power 3 e to the power minus 2x. So that is y prime. Then minus 6y. So minus 6y. So this is why I'm going to multiply this one by 6. And let me copy this one down there so that we can look at it and write. Good. So let me paste it here. So I want to multiply this one by 6. So it's going to be plus, is it positive? Oh, it's minus. So I want to multiply this through by minus 6. So minus 6 a naught x e to the power minus 2x minus 6 a1 x squared e to the power minus 2x, and then minus 6a 2x to the power 3 e to the power minus 2x. And the whole of this should be equal to x squared e to the power minus 2x. This is crazy. So here we are going to group the items with all the x's with x to the power 3, x squared, and x, and then the constant term. So let's look at the constant terms first. This has no x. This one also has no x. This one has no x. This one has no x. Anyone again? No. So the one that has no x is 4 of them. We have 4 of them. So this is x naught. This is a naught, a naught, a naught. So minus 1, minus 2, minus 3 will be minus 2 will be minus 5. And then we have a1 here. So this is going to give us 2a1. Then this one is going to give us 5. So minus 5 a naught all times e to the power minus 2. So this is what I'm going to get. Okay. Now another thing that we can do here is now look for the one with x. So let's look for them. The one with the x is, we have this one too is with x, this one with x, this one with x. this one with x, this one with x, this one with x. Good. So all the one with the green is the one with the x. So let's go through and see if we can add some of them. So we can see a naught, a naught. Do you have another a naught with the green? Yes. We have another a naught here. We have another, no, we don't have another a naught again. So the green ones are 1, 2, 3, 4, 5, 6, 7. And out of 7, we have this and this and this, giving us a naught. So you can see that this is 6, right? We have 6, and then this and this will be 6. So they are going to cancel out. Good. So this will cancel this and that because it's going to give us 6. Now let's look at the other a naughts. Let's look at the other x. So we have the one with the green, we have x a1 here, we have a1 here, and then we also have a1 here. Is that right? Yes. So this is -2, -4, -4. So this is going to give us minus, so plus -10 a1. So that's what we have. So combining this, this, and that. And then the last one with x is this one, which is plus 6 a2, and we are going to multiply by x to the power of this. So that's what we are going to get. So we are done with the one with x. Let's look at the one with, let me say, x squared. So this one have x squared. This one also have x squared. This one have x squared. This one also have x squared, x squared, x squared. So the one with the black, they are the x squared people, right? So we have 1, 2, 3, 4, 5. Good. So x squared with x2, we have 1, 2, 3. So 1, 2, 3 is the x squared with x2. Sorry, a2. So -3, -6, -6. This is going to give us -15. Is that right? Yes. So plus -15 a2. So we are done with this ones. So this, this, and that. Now let's look at the one with a1. So this is a1. This is also a1. And this is also a1. Good. So let's look at what happens. This is plus, and this is minus. So they will cancel out. So this will cancel this and cancel that. So the one that we've not underlined is the x to the power 3. So this all underlined, this all underlined, this all underlined except with this. Underline, except with this and this. So the one left is this guy, and this guy, which is x to the power 3. And we can see that it will cancel out because I can see that this is 6, which is negative, and this is the 2 plus 4 is also 6, which is going to cancel out. So this is what we are going to get at the end of the day. So it means that since the other one cancel out, this one is supposed to be going with x squared e to the power -2x, and this will be equal to x squared e to the power -2x. So this is a whole lot of work. So now what can we do now? Now we compare the same idea, x squared e to the power -2, x squared e to the power -2. So we can see that -15 a2 should be equal to 1. And this implies that a2 is equal to -1 divided by 15. So that is a2. Now when you look at this, this has no term here on the right because we don't have any term on the right. That is this. So it means that we are going to have -10 a1 plus 6 a2, which is equal to 0. Good. Let me put this one here. And then this one too has no term. This one also has no term on the right. So this will be also equal to 0. So I'll clean the board and then, so 2a1 minus 5a0 is also equal to 0. So let me clean the board small so that we can shape things up and then we'll be done. Okay, so let me clean some of this that we did here. Good. So let me move this one up. Good. So we are going to have, now that we have this one to be equal to 0 and this one too to be equal to 0, now we have a2. So we can use a2 to find a1. So this implies that minus 10a1 plus 6 times 1 over 15 is equal to 0. Minus 10a1 plus 3 goes here, 2, and goes to 15, 5, 3, 5, 15. Okay, and goes here 5, which is equal to 0. So minus 10a1 is equal to 2 divided by 5. And when I divide through by 10, I'm going to have it to be a1, which is equal to minus 1 divided by 25. Now that I've gotten a1, I can use a1 to find a0 here. So I'm going to have 2 times minus 1 over 25 minus 5 a0, which is equal to 0. So this is minus 2 divided by 25 minus 5 a0. And then I'm going to have this one to be minus 5a0 to be equal to 2 divided by 25. And when I divide by 5, I'm going to have a0 to be equal to minus 2 divided by 25 times 5 is going to give us, I think, 125. Is that right? Yeah, I think so. That's right. 125. So it's going to give us 125. So this will be the solution. So let's go and put them inside and see what we are going to get. So I'm going to have something like this. So from the particular solution, we have it to be this form. Good. So when I do substitution, yp will be equal to a0 is minus 2 over 125 x e to the power minus 2x. a1 is minus 125 minus 1 over 25, which is x squared e to the power minus 12. a2 is minus 15, minus 1 over 15. So minus 1 over 15, then x to the power 3. So this is a whole lot of work on its own. So now, finally, we just add the complementary solution to the particular solution to get our general solution. So our general solution now is going to be complementary solution, which is c1 e to the power 3x plus c2 e to the power minus 2x plus the particular solution. So minus 2 divided by 125 x e to the power minus 2x minus 1 over 25 x squared e to the power minus 2x minus 1 over 5 x cubed x to the power e to the power 2x. So this will be the general solution. Good. So this will be the general solution. This will be the general solution. Good. So this is our general solution for question 2. Let's take this last question and then we look at trial question. So the same thing here, general solution. So we see the different form. This one too will give us a different form. So general solution, y is equal to yc plus yp. So for yc, y prime prime minus y prime plus y should be equal to 0. And then y is equal to e to the power mx. Y prime is equal to m e to the power mx. And y prime prime is equal to m squared e to the power mx. So let's do substitution. M squared e to the power mx minus 2 times mx plus mx is equal to 0. Factor e to the power mx out. We have m squared minus 2 m plus 1, which is equal to 0, right? We make sure that this is never 0. So the polynomial function will be m squared minus 2m minus plus 1. And then we find the roots. So m squared minus 2m plus 1 is equal to 0. Can I get factor for this without using the quadratic? Yes, I think so. So this is m squared minus m plus 1. Good. So this is true. So factor m out, and the first side with the red, and then this side with the green. When I factor minus 1 out, I'll be having m minus 1, which is equal to 0. So this is going to give us m minus 1, which is equal to 0. And then m minus 1 is equal to 0, and m1 is 1. M minus 1 is equal to 0, and m2 is also 1. So it means that we have real values but repeated. So our complementary solution is going to be c1 e to the power mx plus, or m1x plus c2 x e to the power m1x again, because they are all the same. So complementary solution will be m1 e to the power x plus x2 e to the power x. So this will be the complementary solution. Let's just go through quick by looking at the particular solution, then I'll give you a trial question to do. So y prime prime minus 2y plus y is equal to x e to the power x. And then the complementary solution is equal to c1 e to the power x plus c2 e to the power x. So general solution is this. So we need yp. So for yp, this is an exponential and a polynomial function. So first, our trial solution, we look at what is here. So this is a linear function. So you are going to have a linear function a0 plus a1x. Then we multiply it by the exponential function. So this is what you are going to get. Now let's expand and see what we are going to get. a0 e to the power x plus a1x e to the power x. Now we see that e to the power x is actually inside this equation. And this one here is the same as this term, right? So we need to modify it. So we modify this by multiplying through by x. So multiply through by x, you get a0 x ex plus x1 x squared e to the power x. Now compare again, and we see that now we don't have any term with ex and constant, but this term here is also the same as this, because we have the x and ex again, which is also here, and the constant and a constant. So we need to modify it again by multiplying through by x. So x0 x squared e to the power x plus x1 x to the power 3x. So now that when you look at this one, we have ex, but the x term is starting from x to the power 3. Then this, we can consider this as the trial solution and clean up the first one. So this is what we are going to use for the trial solution. So let's differentiate, and then we just go. Product rule is going to give us x squared e plus 2x ex. Then we have another product rule, x to the power 3 ex plus 3x squared ex. Right? So product rule, First, I maintain x squared and differentiate e to the power x. I get the same thing. Plus, now I maintain e to the power x and differentiate x squared and I get 2x. Same here, maintain e to the power x and differentiate x to the power 3. Sorry, maintain x to the power 3 and differentiate e to the power x. You get the same thing. Plus, maintain this and differentiate x to the power 3. You have something like this. So now let's look for y prime prime. And this is going to be a naught. Differentiate this, product rule again. So in the middle here, I'm going to maintain x squared and differentiate ex, plus now maintain ex and differentiate x squared. You get 2x, something like this. Plus here, I'm going to maintain 2x and differentiate ex, and then now maintain ex and differentiate x. I get something like this. Plus a1, same here, maintain this guy here, this, and differentiate ex, plus now maintain ex and differentiate x to the power 3. Then the last part, maintain 3x squared and differentiate ex, plus now maintain 3ex and differentiate x squared. You are going to have 6x e to the power x. So this is the y prime prime. So I think we can do something to the y prime prime. So we are going to have a naught, the middle term are the same. So we are going to have x squared ex plus 4x ex plus 2ex plus a1. Then the middle term here too is the same. So we are going to have x to the power 3ex plus 6x squared ex plus 6x ex. So now let's plug them inside the original equation, inside this one, and then we are done with this. So we know that y prime prime is the whole of this. So I'll write them by expanding it. So I'm going to have a naught x squared ex plus 4 a naught x ex plus 2 a naught e to the power x. So here, when you are doing it, you need to pay attention to the expansion, because one mistake will just blow up everything that you are doing here. Because even if you make a mistake with the differentiation, it blows up everything that we are doing here. Good. So I just multiply through by a1 and a naught. So this is y prime prime. Then I'm going to multiply minus 2 to y prime. So I'm going to have minus 2 multiplied by y prime. So I'm going to multiply a naught true and a1 true. So I'm going to have a naught x squared ex plus 2 a naught x ex plus, then I multiply a1 true here. So I'm going to have a1 x to the power 3 ex plus 3a1 x squared ex. So that is y prime. Then plus y. So this is y here. So y is a naught x squared e to the power x plus a1 x cubed e to the power x. Is that right? And the whole of this should be equal to e to the power x e to the power x. So now we expand, then we cancel. A lot of work. So what I'm going to do here is I'm going to write everything here again. So I want to copy it. So I'll copy it and paste. Good. Then remember, I copied the whole of this. So it's left with this one. So I need to write it in addition. So I write plus. So this one was supposed to be plus here. Let me check if we did the writing good. So it's supposed to be plus. So plus 6a1 x e to the power x. Then I'll expand this by multiplying through by minus 2. So I'm going to have minus 2 a naught x squared ex plus 4 a naught x ex. No, this one is supposed to be minus again x cubed ex minus 6 a1 x squared ex. Then the last one is plus a naught x squared ex plus a1 x to the power 3 ex, and is equal to ex. Good. So now we look at the term and we see if we can cancel some terms out or if we can add some terms out. So same idea, look for all the terms without x, right? So let's look for them. Without x, we have one here. Without x, it's just one. Oh, wow, interesting. So without x is just 2a naught e to the power x. Now let's look for the term with x. This is with x. This one too is with x. This one with x. Finished. So the one with the blue is the one with the x. So I can see that this one can cancel this, and then it will be left with plus 6a1 x e to the power x. Good. Now let's look for the terms with x squared. Terms with x squared. This is x squared. This is also x squared. This is x squared. And this is x squared. Is that right? Yes. What was the first term here? Okay, this is 3. Let me write it well. So the terms with x squared, and then what is this one again? This one is supposed to be a1. Good. So let's see if we can cancel. A1 is here. Another a1 is here. No, we are looking at x squared. So a1 is here, a1 is here. So this one will cancel out, right? So this one will cancel this one out. And then what is this term here? This term here was coming from this term. Good. And then this term here was coming from this term. Good. All right. So do you have a squared again? Let me go and check my function here and see. Okay, so this should be a squared. Okay, so this one is squared. Indeed, this one is squared. So that one too is red. So this term and this term and this term will cancel out. Then the one with s to the power 3 is left with this term, and this term. That one too is going to cancel out. So this will cancel this and cancel that. Because when I add this and this will be 2 and this one will be going out. So it means that we are going to have this one to be equal to e to the power this. So here when you are doing it, you need to pay attention. If not, you get it wrong. So pay attention with the expansion and then you are going to get it right. So now let's compare this and that. So 6a1 is equal to 1. This implies that a1 is equal to 1 over 6. Then 2a naught e to the power x, 2a naught is equal to 0 because we don't have any term here with e to the power x. And then a naught will be equal to 0. So a naught is 0, a1 is 1 over 6. So let's plug them in here. So with this one, we are going to have our particular solution. We know that a naught is 0, so everything here goes to 0. And then we are going to have a1, what is 1 over 6? So 1 over 6, x to the power 3, e to the power x. So now let's add the complementary and then to get our general solution. So general solution is going to be y equals c1 c2x ex, then plus 1 over 6 ex. So this is going to be our general solution. This is going to be our general solution. This is going to be our general solution. So this is our general solution. This is our general solution. which is very nice. Good. So this is the end of the video, and so now we've gone through three things, or we've gone through three cases. Case one, when it involves with only exponential function, I mean the non-homogeneous aspect, and we looked at polynomial functions, and then we looked at adding polynomial function and then exponential function together, right, or multiplying them together in this video. So in the next video, we are going to talk about case three, where we have trig functions and the exponential function all together. So go through this question and leave your final results in the comment section. See you in the next video.